Good morning. Today we are going to see the dynamic logic design. So why we go for dynamic CMOS? And what is the difference between dynamic and static? In static circuits, the output is connected to either ground or VDD and it requires two end devices for implementation. But when you go with the dynamic, which is related with the switching activity, and there is a temporary storage of signal values on the capacitance, so which will be acting as a high impedance node. Just look into the circuit, so still we can understand in a very better way. So if you look into the circuit, you have a clock signal, so this is going to be the clock. So whenever clock is equal to 0, PMOS is going to conduct and it enters into the pre-charge phase. And whenever clock is equal to 1, evaluation is going to start. So pre-charge. So pre-charge means this VDD is going to be charged and that VDD comes to the output by means of the PMOS transistor where it is going to be in an on condition and output will be equal to VDD and that signal is stored by the capacitor CL. So when it enters into evaluation, so clock is equal to 1, pull down network is going to have the logic implementation. So you can have any logic to be implemented. Say for example, in this circuit, we have A dot B plus C the whole bar implementation. So we can implement using NMOS and then we have a clock for the switching activity based on the clock. This is a clock bar and clock. Clock bar is nothing, pre-charge phase, and clock is going to be the evaluation phase. And some of the features are going to be listed out. So N+2 transistors are needed and it should be smaller in area and full swing outputs are expected and we can realize all these logic functions. So these are the features we have in dynamic. So we'll continue in the next session.